Hello students, welcome. So today we are gonna discuss on division algorithm. So our next topic is division algorithm. Okay, so I guess everyone knows how to operate that division operation. So if I ask you that divide 15 by 7. So if I ask you divide, you need to divide 15 by 7. Okay, so what you will do, you will just carry out the division operation. Okay, 15 divided by 7. Okay, what 7 into 2, it's 14, and remainder is 1. So you can express 15 as 15 equal to what? 7 into 2, that is 14. 7 into 2, that is 14, plus 1. Okay, you can express 15 as like this. So here 15 is called the dividend, 7 is called the divisor, 2 is called the quotient, and 1 is called the remainder. Okay, now if I ask you that you need to divide 14 by 7. Okay, so now carry out the division operation. 14 divided by 7. Okay, it's 7 into 2, it's 14, cancels out, and the remainder is 0. So here you can express 14 as 7 into 2 plus 0. Okay, here I suppose that you have come across this relation that dividend is equal to divisor into quotient plus remainder. So this basic expression in your lower classes. So when you carry out the division operation on any number, let's be an integer, by any other integer, and that integer must not be equal to 0. Okay, because if you divide anything by 0, it is undefined. Okay, if you divide anything by 0, so let if I say that a belongs to an integer. Okay, if I divide a by 0, it is undefined. Okay, it's undefined. So so the divisor, so the conclusion is that that the divisor cannot be equal to 0, because if you divide anything by 0, it is undefined. Okay, so from this we get a conclusion that when you divide any number, when you divide any integer by any other integer, and that divisor must not be equal to 0, then you get a quotient, and along with that you get a remainder. That remainder can be 0, like in this case, or it can be any other integer. Okay, so with this idea, the first theorem of division algorithm can be stated as. So the theorems are as the first theorem states that for two integers a and b with b greater than 0. Okay, so a has no restriction. It can be a positive integer, it can be 0, or it can be a negative integer. Okay, but b has restrictions. B cannot be equal to 0. Okay, b cannot be equal to 0, because if b is 0, if you divide a by b, then a divided by 0 is undefined, right? So b cannot be equal to 0. And also, for the sake of convenience of the proof of the theorem in your book, b is considered to be positive. Okay, it is not considered to be negative. So b is a positive integer. Okay, then there exist unique integers q and r. So it is said that there you will find two unique integers q and r such that this condition is satisfied. So if you just look into this relation, it is nothing but it is like dividend is equal to the dividend, which we discussed a few minutes later ago. So it is dividend is equal to you can write divisor into quotient plus r. That is, we are dividing a by b and we are getting the quotient q. Okay, we are getting the quotient q, and after some calculation, let this b into q is x, and after subtracting we are getting the integer r. Okay, so like in the discussed examples earlier, yes, so the remainder can be 0 or it can be an integer. Okay, it can be an integer. So thus we can conclude that where r is, it can be greater than or equal to 0, but it must be less than b. It must be less than b. Because likewise, if I ask you to divide 14 by 7 again, you will not take like 7 into 1 is 7. This is wrong, right? The remainder is again 7. This is wrong, right? So you will consider the maximum case. So 7 into 2, right? 7 into 2 is 14, right? 7 into 2 is 14 and the remainder is 0. You will consider this case, right? So the remainder cannot be greater than the divisor. The remainder cannot be greater than b. That is, the remainder cannot be greater than the divisor. Okay, so this is the theorem, and in a more generalized form, you can just say that a and b belongs to integer. A and b belongs to integer. Okay, a has no restrictions, but b must not be equal to 0, because if b becomes 0 and if you divide anything by 0, it will be undefined. Okay, so b cannot be equal to 0. Then there will exist two unique integers q and r, so that you can write this relation, which is nothing but dividend is equal to divisor into quotient plus remainder, and the remainder can be 0 or it can be greater than 0, but it is always less than b, which is the divisor. Okay, by which number you are dividing, that the remainder must be less than that number. Okay, so now we shall discuss the idea of even and odd integers. Okay, from the first theorem of division algorithm, we consider that a and b to be two integers, and b is not equal to 0, or b is a positive integer, it is greater than or equal to 0. Okay, then a can be expressed as the product of b and some integer q plus some integer which is the remainder. Okay, that is this is nothing but is dividend is equal to divisor into quotient plus remainder. Okay, so then for q and r to be integers, we will get the condition for r is that r is greater than or equal to 0, but is always less than b. So if this b, if this b completely divides a, that is a is completely divisible by b, then the remainder will be 0, right? Then the remainder will be 0. Then this is the case. And if it is not completely divisible by b, then what we will do, then we will get a remainder. And the remainder will be always less than the divisor. Okay, so this was the first theorem, right? Now from the first theorem we will obtain the idea of the even and odd integers. Okay, so let us consider that the b is equal to 2. So let us consider b is equal to 2. Okay, then if b is equal to 2, then what is the required condition for r? Then the required condition for r becomes r is greater than or equal to 0, but it is less than equal to b, which is now 2. Okay, right? So if this is the case, then what are the possible values of r? As r is an integer, okay, so if we look at this condition, then the possible values of r becomes it can be equal to 0, right? Yes, it can be equal to 0. Then which is the next integer? It is 1. Then which is the next integer? It is 2. But will we consider the value of 2 here? No, because r is less than 2, right? So the only possible values of r are 0 and 1. Okay. So applying these two values individually, one by one, on this equation, you will get, consider this to be 1. So from 1, you will get the value of a to be a. Is equal to, what is the value of b? It is 2, right? It is 2 and q. If we consider r to be 0, okay, if we first consider r to be 0, then the value of a becomes 2q when r is equal to 0. Okay, so a is equal to 2q, a is equal to 2q when r is equal to 0. Okay, so we know that q belongs to an integer, that is the value of q is 0 plus 1 then minus 1 plus 2 or minus 2, like this. Yes, so the q is an integer and the respective values of q are this. Then if we substitute the values of q in this expression, what will be the value of a? Then a will be, if we substitute the value of q to be 0, you will get 2 into 0, it is 0, right? Then if you substitute 1, you will get 2 into plus minus 1, that is plus minus 2. If you substitute 2, you will get plus minus 4 and so on. Okay, thus if you notice these numbers, now these values of a, then you can say that these are nothing but these are even numbers, right? These are even numbers. So we can conclude now that when the value of a is equal to 2q, when the value of any integer, if the value of any integer can be expressed as 2 into multiplied by some integer. Yes, q is an integer, right? If you can express any integer as 2 into multiplied by any integer, note the point, q is integer, okay, it cannot be fraction, okay? So if you can express any integer as 2 into multiplied by some other integer, then this integer a will be an even number, okay? Then thus these are nothing but even integers. These are even integers, okay? These are even integers. And now if you consider again from 1, you will get that. Now what is the other value of r? It is 1, right? A is equal to 2q plus 1. Now we consider that the value of r to be 1. We consider that the value of r to be 1. Then if we consider the value of r to be 1, then the value of a becomes 2q plus 1, right? For write down for when r is equal to 1. Now we know that what are the possible values of q? It is any integer, right? 0 plus 1 minus 1 plus 2 minus 2, right? So if we substitute this value of for q to be any integer, that is q is equal to 0 plus 1 minus 1 plus 2 minus 2, right? Dot and so on. Then what the value of a will be? The value of a will be, right, if you substitute 0 in this equation, 2 into 0, it's 0 plus 1, 1, right? You will get 1 plus 1. If you substitute plus 1 in this value, plus 1, you can substitute minus 1, but let's see what we will get by substituting plus 1. If you substitute plus 1 in this expression, if you substitute plus 1 in this expression, then you will get 2 into 1 plus 1. 2 into 1 it's 2 plus 1 it's 3, right? You will get 3. If you substitute minus 1 in this expression, 2 into minus 1 it is minus 1, right? 2 into minus 1 it is minus 2, sorry, 2 into minus 1 it is minus 2, right? Minus 2 plus 1 it is minus 2 plus 1. What is the value? Minus 2 plus 1 it is minus 1, right? So likewise, if you substitute plus 2, if you substitute plus 2 in this expression, 2 into 2 it is 4, plus 1 you will get 5. If you substitute minus 2 in this expression, 2 into minus 2 it's minus 4, minus 4 plus 1, minus 4 plus 1 it is minus 3, right? So you will get minus 3. So now you can, I guess, generalize. You will get what will be the values you will get. We have received plus 1 and we have received minus 1, right? We can write, you will receive plus minus 1. We have received plus 3 and minus 3, so plus minus 3. Likewise, you will also get plus minus 5. So we have received odd integer values. So we have received odd integers. So I guess now it is very clear to you what are odd integers and even integers. So any even integers can be expressed as any even integers can be expressed. So let that integer be a. That integer can be expressed as, if it is an even integer, it can be expressed as 2 multiplied by some other integers. That is, you can express, if this a is an even integer, then you can express it as 2 into multiplied by some other integer. And if it is an odd integer, then you can express a as 2 into multiplied by some other integer plus 1. 2 into multiplied by some other integer plus 1. So if it is an odd integer, you can express it as 2q plus 1. If it is an even integer, then you can express it as 2q. Okay, that is 2 into multiplied by some other integers. Okay, so this is the idea of odd and even integers. Hope it is clear to you. So now we shall discuss some problems. Okay, so, you can write down you can, before we move towards the problem, you can write down the definitions of even and odd integer. Okay, so an integer of the form a is equal to 2q, where q is an integer, is an even integer. So if any integer can be expressed as 2 multiplied by some other integer, then it is an even integer. And if any integer can be expressed as 2 multiplied by some other integer plus 1, then this integer will be an odd integer. Okay, then this integer will be an odd integer. So you can take the example for example, like for q to be 0, 1, 2. Okay, so what you will get, the value, yes, these are positive integers. I have considered the values of positive integers. Then you will get the values of a is equal to what? 0. 2 into 0 is 0. 2 into 1 is 2, right? 2 into 2 is 4, ... and so on. Okay, and if we consider this case, so for q to be here, I will consider the negative integers. Okay, if I consider the values as ... let it be minus 2, minus 1, 0 and 1. Okay, we'll consider this. Then what will be the values of a? If I substitute minus 2 in this expression, 2 into minus 2 it's minus 4, minus 4 plus 1, minus 4 plus 1, what is the value? It is minus 3, right? Then if we substitute minus 1 in this expression, 2 into minus 1 it is minus 2, minus 2 plus 1, minus 2 plus 1 it's minus 1, right? Minus 2 plus 1 it's minus 1. Okay, and if I substitute 0 in this value, likewise, if 2 into 0 it's the whole, this becomes 0 plus 1, 0 plus 1 it's 1. Okay, so and if I substitute 1 in this value, if I substitute 1 in this value, 2 into 1 it's 2 and plus 1 it's 3. 2 into 1 it's 2 and plus 1 it's 3. Okay, so you will get the even values, right? Like plus minus, you got plus 1 and minus 1, so I write it as a whole, so I write it together. Okay, so it's plus minus 1, plus 3, minus 3, plus minus 3 and so on. So these are odd integers. Okay, so now let's discuss a problem. Okay, so it is so that the square of any integer is expressible in the form 4m or 4m plus 1, 4m plus 1. Okay, 4m plus 1, where m belongs to integer. So what the basic idea of this statement? Okay, just focus on that square of an integer. So just consider some examples for our better understanding. Okay, square of any integers. So let us consider any integer, for example, like let us consider plus 3. Okay, plus 3. So if we square this number, the square of an integer, yes, square of an integer, so let us square this number. So what will be the value of plus 3 square is equal to, it's 9, right? 3 square is equal to 9. Then you can express 9 as either 4m or 4m plus 1. That is where m belongs to integer, right? So you can express 9 as just as 4 into 2 plus 1. That is 4 into 2, it's 8 plus 1. Yes, we have expressed it in this form, right? We can express 9 it in this form, where 2 is an integer. 2 is nothing but integer, right? Where 2 belongs to integer. Let us consider another example. Let us take minus 2. Okay, minus 2 to be integer. So if we the square of an integer, right? So minus 2 square, if you square minus 2, you will get 4, and you can express 4 as 4 into 1, right? Where 1 belongs to integer, right? So this case satisfies this condition, 4m. Okay, so if for simplicity, I will express, I will tell you that if you square the even integers, then you can express it in 4m form, and if you square the odd integers, then you can express the result in 4m plus 1 form. Okay, so let us prove this statement. Okay, so let solution now, right? Solution. Okay, solution. Let a belongs to integer. So let us consider that a belongs to an integer. Okay, then by the division algorithm, what you can consider that a and let's consider b to be, let's say 2. Okay, so we are dealing with 4m and 4m plus 1 numbers, right? So let us consider that b to be 2. Okay, for a and to be any integers, belongs to any integers. So if a is an integer, so at first we consider that a belongs to an integer, then by the division algorithm theorem, then we can write that a and 2 belongs to an integer. So what we are basically telling is that we are dividing a by 2. Right? So then if we divide a by 2, then we will get a quotient, right? We will get a quotient, and you can get a remainder or you cannot get a remainder. If a is completely divisible by 2, then the remainder will be 0, and if it is not completely divisible by 2, then you will get a remainder, and the remainder will be less than 2, right? So then there exist q and r, okay, where q and r belongs to integer, then there exists q and r belongs to integer z, okay, such that this r, what will be the value of r? It will be greater than or equal to 0, and as we have considered that the value of b to be 2, the value of b is 2, therefore r cannot be greater than 2, right? So r is less than 2. Okay, so this is nothing but this we obtained from the first term. Okay, so considering this case, so you can write the expression, the overall expression as now that what we write, that dividend is equal to divisor. What is the divisor in this case? Now we have considered it to be 2, right? It to be 2. So divisor in quotient into, now you will multiply by the quotient q, right? What is dividend is equal to divisor into quotient plus the remainder. Okay, so this is the general expression, right? So by this case, as r belongs to an integer, as r belongs to an integer, so if we notice this restriction, then we will get the values of r to be, yes, it can be equal to 0, right? Yes, it is greater than or equal to 0, so it can be equal to 0. And what is the next integer? It is 1, right? 1. And can the value of r be 2? No, it cannot be 2, right? It is less than 2 by the theorem. So if you incorporate these two values individually in this expression, you will get then for r equal to r equal to 0, what is the a value? A is equal to 2q plus 0 is equal to 2q. Okay, and if r is equal to 1, what is the value of a? It is 2q plus 1, it is 2q plus 1. Okay, 2 into q plus 1, it is 2q plus 1. Okay, where q belongs to integer. Okay, so we obtained this two expression that if r is equal to 0, then the value of a is 2q, and if r is equal to 1, the value of a is 2q plus 1. So these are the possible values of a, okay, where q belongs to integer. So now, considering the value of r, what we got the value of a? R to be 0. If we consider the value of r is equal to 0, then the expression for a was 2q, right? So we were to prove that the square of any integer is expressible as 4m or 4m plus 1. So square of any integers. So a is the at first we considered a is to be an integer, right? So now what we are to do, as per the condition, as per the question, we are to square this integer, right? So let us square this number, squaring, square, squaring both sides so that the equality is maintained, right? So squaring both sides, we get a square is equal to 2q square. So what is the value? A square is equal to 4q square, right? Is a square is equal to 4q square. So we considered that q is an integer, right? We considered that q is an integer. Okay, what a belongs to integer and q was also an integer, right? As q is an integer, then q square will also be an integer. Correct. If q is an integer, then q square will also be an integer, right? So if q square is an integer, so we can replace q square by any other integer, say m, for m. Okay, so where you write where m is equal to q square, which belongs to an integer. Okay, so yes, we have expressed our first condition, that the square of any integer, so it is basically the even integers, the square of even integers, right? If we can express any integer as 2q, it is even integers, right? So the square of even integers can be expressed as 4n. And now we will consider the odd integer case. So right now, for I is equal to 1, a is equal to, what was the value? We got 2q plus 1, right? 2q plus 1. So again, by following the same procedure, squaring both sides. So why we have squared actually? Because the statement of the question was like that, the square of an integer, right? So and we have to square. So squaring both sides, what you will get the value? A square is equal to 2q plus 1 square. Okay, so a square. So you know, I guess the formula a plus b whole square formula is a square plus 2ab plus b square. Okay, so you will break this by this form. So 2q square plus 2 into 2q into 1 plus 1 square. Okay, so a square is equal to what? A square is equal to 2q square. What is the value? 4q square plus 2 into 2q into 1, it is 4q, right? Plus 1 square is 1. I guess you can take 4 common. Yes, 4 common. Yes, a square is equal to 4 q square plus q. A square is equal to 4q. Yes, we can take 4 common and plus 1. Okay, so as since q belongs to an integer, then q square plus q will also belong to an integer. And let us consider that this q square plus q is nothing but, let us consider it to be m. So we can now write that 4m plus 1, where m is equal to q square plus q, where q belongs to an integer. Okay, so yes, now we have received that the value of the square of the odd integers to be equal to 4m plus 1, where m is nothing but it is an integer which is the summation of q square plus q. Okay, so by the method of division algorithm, we have obtained two results that for any integer, so whether it be an even integer or it be an odd integer, they can be expressed either in 4m or 4m plus 1 form, where m is an integer. If it is an even integer, then you will get the 4m form, and if it is an odd integer, you will get the 4m plus 1 form, where m is an integer. Okay, so I hope that this video is helpful to you, and we'll continue with some more problems in our next discussion. Okay, thank you.